If you're stepping into the world of electronics, a digital multimeter is, without a doubt, going to become your new best friend. It's just an amazing, completely indispensable tool. Now, I know, looking at it for the very first time, it might seem a little intimidating, right? All those dials, the weird symbols, the different ports, but honestly, there is absolutely no need to worry. In this explainer, we're going to break down every single one of its functions into super easy to understand parts. We are going to reveal all its secrets today so you can pick it up and confidently use it like a pro.
Assalamu alaikum, meet Ismail, an absolute technology genius.
He'll take you from basic electrical theory straight into real, hands-on builds.
Hit subscribe for weekly explainers and let's start building today.
Okay, let's dive into this. Here's our roadmap for today. We'll start with meeting your new best friend, move on to checking AC and DC voltage, play around with the detective functions, learn how to measure current in series, and then we'll wrap up with the golden safety rule.
All right, Section 1, meet your new best friend. Because before we can measure absolutely anything, we have to master the absolute basics of plugging things in correctly.
The setup is actually incredibly straightforward, and there is one rule here that never ever changes. The black probe always goes right into the COM port. You can just think of that as its permanent home. Now, for the vast majority of tasks you'll ever do, your red probe is going to plug into the VOMA port. That's your everyday go-to. You might notice a 10A port on your device too, but we're going to treat that one like a highly specialized tool used only for very high current. We'll touch on that later, but for now, just remember, red in VOMA, black in COM.
Moving right along to Section 2, checking voltage, both AC and DC. This is probably the most common thing you'll use this tool for, like checking if a battery still has any juice left.
But before you even twist that dial, we need to talk about the two types of voltage you're going to encounter. First, you have DC, or direct current. You'll spot this on your multimeter as a straight line or a little dash. This is the power coming from things like batteries. Then you have AC, or alternating current, which is marked by a wavy line or a sine wave. This is the much heavier, higher voltage power coming straight out of the wall sockets in your home. To get an accurate reading and to stay safe while doing it, you absolutely have to make sure your dial is set to the correct symbol for whatever you're testing. So, how do we actually go about measuring DC voltage? It's super easy. Let's say we're testing a standard 12-volt car battery. First step, set the dial to 20 volt on the DC side. The golden rule here is that your selected range should always be just slightly higher than the voltage you're expecting to find. Once you're dialed in, simply touch the red probe to the positive terminal, the black probe to the negative terminal, and boom, an accurate reading is going to pop right up. And this brilliantly illustrates exactly why picking the correct range is such a big deal. When you have the right range selected, like 20V for a 12V battery, you get precision down to 2 decimal places. And trust me, that level of precision matters a ton when you're working with sensitive circuits. But what if we set that range way too high, say 200 instead of 20? Well, the reading is still technically correct, but that vital, fine-grained decimal precision is totally gone. That's exactly why you always want to choose the next highest range closest to your target. Now, eventually, you're going to test a battery and see a negative sign pop up next to your number. Don't panic, you didn't break anything. It simply means you've got your probes backwards. It's actually just the multimeter's really clever way of telling you, hey, your red probe is sitting on the negative terminal right now. This is totally fine. In fact, it's a brilliant little trick if you're ever dealing with a bunch of wires that aren't color-coded and you desperately need to figure out which one is positive and which is negative.
Okay, Section 3, the detective functions. Honestly, this is where using a multimeter gets really fun.
This is all about solving puzzles, like figuring out if a component is dead or tracking down a broken wire. Let's start with resistance, which is measured in ohms. Figuring out the value of a mystery resistor is just a matter of step-by-step deduction. You always want to start with your dial on the lowest resistance range. If you test the resistor and a simple 1 pops up, the multimeter is basically talking to you. It's saying, nope, range is too low, go higher. So you just click the dial up, step by step, until you finally get a real number.
For example, let's say you're stepping up the dial. You hit the 200K ohm setting, and suddenly you get a reading of 99.8. Puzzle solved! That tells you immediately that you are holding a 100 kilo-ohm resistor. It's that simple.
Then we have the continuity test. This is probably the simplest detective function, but you're going to use it all the time. It's just checking to see if electricity can freely travel from point A to point B. It is incredibly satisfying. If the wire is good and the path is clear, you get a loud, continuous beep. If the wire is broken somewhere along the line, total silence. You don't even have to look down at your hands. The acoustic feedback tells you everything you need to know instantly. Moving into Section 4, measuring current in series. Now, we're definitely raising the stakes a bit here.
This is a super powerful function, but it requires us to completely change our physical setup.
So the crucial point is understanding how this is fundamentally different from what we've done so far. When we measured voltage, we just touched the probes to the outside of a live circuit. Easy. But to measure current, you literally have to break the circuit open and force the electricity to flow directly through your multimeter. You are making the tool a part of the circuit itself. It's exactly like installing a meter into a water pipe. The water has to physically flow through the meter to be counted, right? That is what we call connecting in series.
Because all that electrical current is now flowing straight through your device, you have to follow these steps rigidly. Step 1, and this is non-negotiable, physically unplug your red probe from the everyday V-ohm port and move it into that special 10A high current port. Only after you've moved the probe should you turn the dial to the ampere setting. Finally, you connect the multimeter to the broken circuit, completing the loop so the current can flow safely through.
Which brings us perfectly to our final section, the golden safety rule. What we're about to cover right now will absolutely save you from a very common, very expensive mistake.
Let me pose a question to you. What do you think happens if you forget to swap your setup back? Imagine you leave that red probe plugged into the 10A port, and then you just casually go to check the voltage on a battery or a wall socket. Even absolute pros make this mistake when they're in a hurry.
Well, here's what happens, and why you must avoid it at all costs. You create a direct short circuit. That 10A port is designed to let heavy current flow right through it with almost zero resistance. So the electricity suddenly finds this super easy, completely uncontrolled path. The result? You're going to instantly blow the multimeter's internal fuse. Best case scenario, you have to replace a fuse. Worst case, you permanently fry the tool or even start a fire. It's a sudden, violent pop that you definitely don't want to experience.
Now, what's really interesting about this is that the solution isn't technical at all. It's entirely behavioral. You just need to build what we call the golden habit. The literal second you finish measuring current, always, without fail, return that red probe to its everyday home, the V-ohm port. Turn it into muscle memory. The moment you unhook from that series circuit, swap the probe. Do that and you'll never accidentally create a dead short.
And honestly, that's the whole shebang. Any intimidation you had should be completely gone by now. We've revealed all the secrets, from finding the black probe's permanent home, all the way to mastering the golden habit. So the only real question left for you is, what are you going to test first? Are you going to dig through the junk drawer for a questionable old battery? Or are you going to dive straight into a brand new electronics project? Your new best friend is ready and waiting, so get out there and start exploring.